Hi and Assalamualaikum to my fellow final year students and especially my dear panels. My name is Mohamed Arsyad bin Mohamed Mansor and I would like to present my research proposal for PSM1. Before we move forward, I would like to introduce my supervisor, Professor Madya, Dr. Angza Sari binti Muhammad Qasim, and also my co-supervisor, Dr. Mariam Firdaus binti Mat Nordin. The title of my proposal is Extraction of Curcuma species using subcritical water extraction SWE and its characterization study. This is my presentation outline, and I will first explain the introduction, then followed by literature review, methodology, expected result, and finally I also will be showing my research Gantt chart at the end of the presentation. Without further ado, I will explain the research background. Herbal plants have been used in every culture that has ever been in the globe since prehistoric times. The extraction of some of the herbal plants, parts such as root, leaves, flowers and stem, has been found to be a natural remedy that can cure some diseases and or ailments. As for the chosen plants for this research is Curcuma species. Numerous Curcuma species can be found predominantly to be native to Asia. Curcuma plants are found to be anti-allergic, anti-cancer, and also anti-inflammatory. The bioactive compounds need to be extracted from them in order to be functional. But bioactive compounds extracted through using traditional extraction procedures using organic solvent may have negative consequences for that environment and food components. Next is the problem statement. The side effect of prescription medicines are primary cause of death. The reason for this study is to introduce a medicine based on ready and available natural products. Natural medicine can be proven to be as efficient as modern medicine and also be a safer alternative. Conventional extraction method prove to have some flaws, such as a long extraction period and breakdown of the bioactive compounds. Now various innovative green extraction and separation technologies were created to improve the plant extraction procedure. Now we move to the objective. The objectives of the study are first to optimize the subcritical water extraction method of Curcuma species using a response surface methodology. Next objective is to analyze the properties of Curcuma species, extract based on its physical, structural, and chemical. And lastly, it is to evaluate the efficiency of the extracts in terms of its antioxidant and anti-inflammatory activities. We move on to the scope of study. The plant samples selected for this study are Curcuma longa and Curcuma xanthorrhiza. The methods of extraction proposed to extract the bioactive compound from Curcuma longa and Curcuma xanthorrhiza is subcritical water extraction. The bioactive compounds extracted will be going through various analyses in order for them to be categorized. The analysis performed for the characterization will find the characterization of physical, such as yield, color, size, structural, their functional group and surface morphology, and finally the chemical, which is the total phenolic compound. Moving on to chapter 2, which is the literature review. What is Curcuma longa? Curcuma longa is widely known as turmeric. There are studies about Curcuma longa that have found that it has antioxidant, antimicrobial, and anti-inflammatory properties. The mature rhizomes of Curcuma longa are yellowish brown on the outside and dull orange on the interior. Why do we choose Curcuma longa for this study? Curcuma longa have been used as medicine to treat various diseases since traditional time. Curcumin, which is the bioactive compound in Curcuma longa and responsible for the yellow color of the plant, is now regarded as a promising new medicine that being used as a supplement in a number of countries. A researcher by the name of Floria states that curcumin extract, when mixed with nanoparticle technologies, might be able to even fight COVID-19. So another plant, which is what is Curcuma xanthorrhiza. Indonesians have been consuming Curcuma xanthorrhiza as jamu since ancient time. Why do we choose Curcuma xanthorrhiza? Because Curcuma xanthorrhiza can be distinguished from Curcuma longa, which is its sibling, by the presence of xanthorizole. Xanthorizole have been found to have antibacterial, anti-inflammatory, and also antioxidant properties. Here I show you the structures of bioactive compound inside both Curcuma longa and Curcuma xanthorrhiza. Both Curcuma longa and Curcuma xanthorrhiza have curcumin, dimethyl-C-curcumin, and bis-dimethyl-C-curcumin. These three compounds can be actively seen in both of the plant, but in Curcuma xanthorrhiza, but for xanthorizole, it only been found inside Curcuma xanthorrhiza. Why do we choose SWE method? When extracting bioactive compound using conventional methods such as chocolate extraction and hydrodistillation takes much longer time and resources. These methods also uses solvents that are harmful to be used for extractions of plants' bioactive compound such as methanol. SWE only uses water as a solvent to extract the bioactive compound. Moving forward to the methodology. We first begin with sampling and screening of Curcuma longa and Curcuma xanthorrhiza. Both the rhizomes will be cleaned and cut to small pieces. The sample will then be dried in an oven to remove moisture and to prevent any microbial growth from happening on it. The dry sample will then be grinded into powder. The next step is the optimization of subcritical water extraction for Curcuma longa and Curcuma xanthorrhiza using a response survey methodology, RSM. The SWE parameter that will be prioritized are the temperature, extract time, and pressures. By following this parameter, the RSM will respond to the product yield, total phenolic compound, total antioxidant activity. Next step is the characterization analysis of optimized extract, where the physical, structural, and functional group of the bioactive compound will be studied. And the final part of the research is the development of green SWE method of Curcuma longa and Curcuma xanthorrhiza, where the sample yield will be measured. As for the expected result, it is expected that both plant extract from Curcuma longa and Curcuma xanthorrhiza are able to exhibit antimicrobial, anti-inflammatory, and also antioxidant activity. It is also expected that extracting bioactive compounds using SWE will produce better yields compared to other conventional methods. It is to be expected that both plants' bioactive compounds to be successfully characterized. As a conclusion, the reasons for using SWE as an extraction method is so that this eliminates the danger of using harmful solvents such as methanol to extract consumable and highly beneficial bioactive ingredient. With the use of the SWE, now the extracted product can be safely used in other development such as medicines, dietary supplements, and many more. The analysis performed in this study will help to confirm the effectiveness of SWE as a green extraction method to extract Curcuma species. So that's all for me. Thank you.